Researchers hid secret commands inside fake bug reports on GitHub, and popular AI coding tools like Cursor and Codex ran those commands 2 out of 3 times, even when the command was completely invisible to any human reading the report.
No, I don't buy it. These tools have security baked in. A locked sandbox, warnings, the works. 2 out of 3? You're going to have to prove that to me before this is over.
That's a fair challenge. So picture hiring a contractor to fix your kitchen. While they work, they find a sticky note taped inside your mailbox. Also, hand the spare key to the person at this address. A careful contractor asks, "Did the homeowner actually write this?" This one can't tell your instructions apart from any note it happens to read, so it just does it. And here's the part that matters. That note can be written in invisible ink. You'd never see it, but the contractor reads it fine.
Okay, but invisible ink. Come on. If a human can't even see the command, wouldn't the tool treat it as junk too?
That's exactly the assumption this paper goes after, so hold that thought. And this isn't hypothetical. If you let one of these tools auto-fix issues in your code, anyone on the internet who can file a bug report is that note in your mailbox. Now I want your bet. These agents ship with safety features, a sealed box they run inside, and a warning stamped on any outside text that says, "Don't treat this as instructions." When the attacks came, did those safety features stop them? Or did they do nothing? You have to pick a side. And watch one specific thing. Every agent keeps a little rulebook file listing which commands it can run without asking. You'll want to remember that file. One attack walks straight up to it.
I've got the rulebook file. Got it.
So here's what they built. They took real, unresolved bug reports from 2 well-known Python projects and hid an attacker's command inside each one, dressed up as a routine setup step you supposedly run before fixing the bug. They smuggled it in every way you can imagine. The issue text, an attached PDF, a code comment, and yes, white text on a white background. Then they fired over 4,000 of these at 3 of the most popular coding agents.
And the agents just went and ran them? Like, this looks like setup, so sure, let me install this?
2 out of 3 times? Yes, they did. And now we get to your invisible ink question. If the tool could tell a real instruction from smuggled attacker text, hiding it should change everything. Hiding it changed nothing. The invisible version worked just as often as the fully visible one, because the tool reads what the text says, not how it looks.
So, before we go on, why not just wrap the outside text in a big "ignore this" warning? Because to the tool, that warning is only more text, and it talks itself right past it.
Right. And the reason these slip through is almost boring. Installing a software package is such an ordinary developer move that it doesn't look like an attack. It looks like Tuesday. Even the most careful model couldn't resist a plain "install this package" request. That's your rulebook file coming back into view, by the way. But first, I need your guess.
All right, the sandbox, the untrusted warnings, those had to catch most of them. Say, most got blocked by the built-in security.
Essentially, none of them were. Of every attack that got refused, the built-in safety software blocked basically 0. And the proof is clean. The same model was dropped into 2 completely different tools, and if the tool's security were doing the work, the refusal rates would differ. They came out identical. Same model, different box around it, same result. Only the model's own judgment ever said no, and that judgment is all over the map. The careful one refused nearly 6 times out of 10. Another one refused almost nothing at all.
So, the sandbox, the whole reason I'd feel safe, did nothing?
Nothing you could measure. So, your bet. Did the safety features stop the attacks or do nothing? They did nothing. And that rulebook file? One attack simply rewrites it. It edits the agent's own settings so dangerous commands get auto-approved from then on. It's the smuggled note telling the contractor to stop checking with the homeowner ever again.
Okay, and this is the small print I'll say out loud. This is one study, the first of its kind, on just 2 code libraries, run in the most reckless mode there is, with every command auto-approved and no human clicking yes. Nobody's repeated it yet, and it shows the worst case, but nobody's saying your setup is already broken.
And that worst case is exactly where you are the second you hand over the keys and walk away. So here's the question to sit with. Would you let one of these agents fix your bug reports on its own, knowing anyone who can comment on an issue gets a shot at your machine?
Papers this strange land here every single day. and one quiet subscribe catches you tomorrow's.
And if you want to know whether this holds up, watch for the next version of these tools to say they've patched it. Then watch someone run this same test again.